Right, coming to the next topic, parallel combination. Parallel combination of resistors or resistors. So previously we discussed series combination and their respective some problems. So in series connection, all the resistors are connected in series by the ends of the resistors are connected. Then we can say that series connection. Then coming to the next connection, parallel connection of resistors or the resistances or parallel connection. What happened if all the resistors are connected in a parallel? So this is the parallel connection. So this is the point A and this is the point B. So two or more resistors are connected between the same points. They are said to be parallel. They are said to be in parallel. So from this point to one resistor is connected. From this same point to one more connected. So such one is called as a parallel combination. So what happened? According to the law of combination of resistance in parallel, the reciprocal of the combined resistance or the equivalent resistance or the resultant resistance of a number of resistance connected in parallel is equal to the sum of the reciprocals of all the individual resistors. To increase the resistance in a circuit, we connect all the resistors in series. To reduce the resistance in a circuit, all the resistors are connected in parallel. So reciprocal of resultant resistance or the equivalent resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In this case, when the number of resistances are connected in a parallel, then their combined resistance is less than the smallest individual resistance. Right? The equivalent resistance of the parallel combination. The total or the equivalent or the resultant resistance is less than the resistance of individual resistance of a resistor. In case of series connection, the resultant resistance is more than the resistance of individual resistor. Right? So 1 by R is equal to 1 by R plus 1 by R plus 1 by R3. That will derive this equation. So equivalent resistance in parallel. So this is a circuit diagram. So R1, R2, R3 are the three resistors which are connected in a parallel. So each one is the parallel. Here observe that the ends are not connected. The ends of the resistors are not connected directly. So they are looking like R3 are the parallels. 3 are the parallels. So according to the Ohm's law. So according to the Ohm's law, we know V is equal to IR. Here, in case of series connection, current is same throughout the circuit, potential difference is same. Here, current is different and potential difference is same. same voltage of current is passed through all the resistance. So then amount of current is passing is different. Amount of current is passing different. So from Ohm's law, V is equal to IR. From that we can write I is equal to V by R. I is equal to V by R. For first resistor, I1 is equal to V by R1. For I1 is equal to V by R1. Current. For first resistor, I1 is equal to V by R1. For second resistor, I2 is equal to V by R2. For third resistor, I3 is equal to V by R2. So consider as equation 1, 2, 3 as 4. So different current. Let us RB is the equivalent current, equivalent resistance. Substituting the I values. Substitute I all the values to know the resistance. Current is saying the resultant resistance I is equal to the resultant. To find out the equivalent resistance or to know the resultant resistance or the combined resistance. So from the Ohm's law, we can get I is equal to V by R. I is equal to V by R. So from equations 1, 2, 3, 4. From the equations 1, 2, 3, 4, V by R. So instead of here we will write R cube. So is equal to. So we can write here I is equal to I1 plus I2 plus I2. For know the resultant resistance, first we know the total current is passing here. The total current passing in the circuit. Right? When a number of resistors are connected in parallel, then the potential difference across each resistor is same. Potential difference is same. So that's why potential difference for three resistors is only V. So then resistance is different and current flowing through the resistance also different. When a number of resistors are connected in parallel, join the terminals of the battery, the different amounts of current flow. Potential difference is same in parallel connection, but different amount of current is flow in the resistors. Depends on the resistance of a resistor. But the current flowing through all the individual parallel resistance taken together is equal to the current flowing in the circuit whole. So in a parallel combination, voltage or the potential difference is same. Then the current is flowing through the resistors depends on the resistance of the resistor. So different amount of electric current is different amount of current is passed to the resistors. The total current is the sum of current flowing in each conductor or each resistor. So I is equal to I1 plus I2 plus I3. From equations 1, 2, 3, 4, you can write I is equal to V by R cube. Then this is write as V by R1 plus V by R2 plus then V by R3. So you can write again here 1 by R into is equal V by R1, V by R2, V by R3. So in all those cases V is the common. So we can write R eq is equal to, write V common, then write 1 by R1 plus reciprocal of equivalent resistance or the resistance or the resultant resistance is equal to sum of reciprocal of individual resistance of the resistors. The reciprocal of equivalent resistance or the resultant resistance is equal to the sum of reciprocals of resistance of individual resistance. So from this we can write by rearranging we can write R eq is equal to, let us take the LCM. Let us take the LCM. So from this we can write LCM R1, R2, R3, R1, R2, R3. Then finally we can write R1 plus R2 plus R3. So this is Req. Then we can write R equivalent is equal to reciprocal. We can write R1, R2, R3 by R1 plus R2 plus R3. So we get this. We get this. So this is about the parallel combination of resistors. 3 resistors R1, R2, R3. So having different amount of electric current is passed from the Ohm's law all these. So advantages of parallel combination in household appliances, for household appliances. So in case of series, if one switch is if one electrical appliance is not working, remaining are not working. But in case of parallel connection or parallel combination, if any one of electrical appliance is not working, then the remaining are working, because as every electrical appliance has own switch. For fan one switch, for bulb one switch, for heater one switch, for fridge one switch, for TV one switch we have. So in household, all the electrical appliances are in a parallel combination. If fan doesn't work, then the remaining all electrical appliances are working, because of each electrical appliances have different connections and have the same voltage of electric current, because same voltage of electric current is passed through each electrical appliance, because they are connected parallelly, each electrical appliance having different potential difference. So same voltage of electric current is passed, electric voltage is passed. The overall resistance of the household appliances are reduced. The overall resistance of the household resistance is reduced in case of parallel. So each electrical appliance get the same voltage as that of power supply line. Due to this, all the appliances will work properly. For example, all the bulbs connected in the parallel circuit get the same voltage of 220 volts of the power supply line and hence glow brightly. Through the fridge same. In parallel connection of electrical appliances, the overall resistance of the household circuit is reduced, due to which the current from the power supply is high. We are using different electrical appliances. All the electrical appliances are consume different amount of electric current. So every appliance can take different amount of current or require amount of current. For example, in a parallel circuit, even the high power rating appliances like electric irons, water heaters, air conditioners draw the higher current needed for their proper function. For bulb require less current. For fan required current. For ACs required more current. So together the total resistance is reduced. Total resistance of household electrical appliances are reduced. This is about the parallel combination of resistors. Parallel combination of resistors. So I hope you understood about the parallel combination of resistors. Then next class we will discuss some problems.